Hi, welcome back. This is a review for AP Precalc 1.1 through 1.6. I've selected a few questions that we will be going over so we can review for any upcoming test. These questions apply strictly to my schedule and what I've been reviewing for, but if you guys have any specific ones, I'm willing to go over them and see what I can work with. So for this specific question, we're asked to write the equation secant line. We're given the function f of x equals 5 over 2x minus 4. And we're given the x values from which they want us to find the secant line. So we have x1 equals negative 2 and x2 equals 4. So what we first must do is plug in our x's. So f of x, which would be negative 2, is 5 over 2, negative 2 minus 4 equals, and then f of 4 equals 5 over 2 times 4 minus 4 equals. All right, so 5 times negative 2, negative 10 divided by 2, negative 5 minus 4, negative 9. Okay, 5 times 4, 20 divided by 2, 10 minus 6, 6. Minus 4 equals 6, sorry. All right, so now we have our x's and we have our y's, which now we can find the average rate of change, which is also known as slope, which would be y2 minus y1 over x2 minus x1. Right? In this case, that would be 4x minus negative 2. And then we have our y's, which is y2 equals 6 minus negative 9. We know these negatives become positives, and then we have 15 over 6, which we can simplify to 5 over 2. All right? So now we have our slope, which is equal to m, which is 5 over 2. And our equation for the secant line is y equals mx plus b. Now, since we have m, all we need to do is find out b. So let's do that. In this case, we can choose one of our x values and one of our y values. I'm going to choose the positives, so we're going to go with 4 and 6. Okay, so now we plug in. We plug in our 6 for our y is equal to 5 over 2, and our x is 4, plus b. Now we solve. 5 times 4 is 20, divided by 2 is 10. So we're going to subtract both sides by 10, which gives us negative 4 is equal to b. So our final answer in the secant line is y equals 5 over 2 x minus 4. This is our answer. Right? Moving on. Determine the degree of the polynomial. So here we have our x values on the top and our y values at the bottom. What we need to do is determine the degree. So is it x to the power of 1, x to the power of 2, or x to the power of 3, and so on. All right? So in order to find this out, we need to do the rate over change, and we have to keep going the rate over change over the rate of change. So negative 14 minus 30, and then divided by negative 2 minus 3, and then addition is equal to 16 over 1. And then we keep going for all of them. If all of them had been the same, like the rate of change was the same for this first line, it would have been linear. So that means to the power of 1. But they're not. So we have to keep going and find the rate of change of the rate of change. So from these, we get negative 14, negative 2, 10, 22, and 34. Again, we did not find it, and this would have gave us a quadratic which is x to the second power. So now we must find the rate of change over these, which gives us 12, 12, 12, 12. And since all of them are the same, this is a cubic polynomial, which means it'll be x to the third power, which would also mean it is an odd function, which means it would go either like this or like this. Okay? And the way to explain it would be because it's cubic because the ROC of the ROC means rate of change, by the way, of the rate of change is constant. So 1, 2, 3. And it took us 1, 2, 3 times to find the average rate of change. All right? So that's the answer for that one. Now we're going to move on to this question. When we see a function like this, we tend to get fooled by the fact that it gives us the average rate of changes right here. And most people would go with this answer right here because they're like, oh, the average rate of change, 10 spaces over, that's the greatest. But that actually is not the case. We have to look at it in a sense of from 0 to 1, so you're moving one space, and that's like 10, right? Like you move 10 over, and like you move, let's say, okay, you move one space over, and that's 10 inches. Okay. But from 1 to 4, you're moving 3 spaces, and they're each -5 inches, or like we're going to the left, right? So now you're actually moving 15 inches back, right? Okay. And then we go to 4 to 8, and we're moving over 4 spaces because 8 minus 4 is 4. And then for this one, it was 4 minus 1, which was 3 spaces. And each space, you're moving 2 inches. So 2 times 4 is 8. So you moved right 8 inches. And then from 8 to 10, we moved 2 spaces, but each of them were 6 inches. 2 times 6 is 12. So the interval from which we increased the most is actually 8 to 10, because every step we took was 6 inches. And we took 2 steps between 8 through 10. However, this one, if we go back to it, we only took 1 step, and that was 10 inches. We moved greater than all of these. And obviously we could cancel out 1 to 4 immediately because we were going in the negative direction. So your answer in this case would be 8 less than or equal to x less than or equal to 10. That's your answer. Okay, let's move on. What this equation is saying is the polynomial function p is given by p of x, which is equal to ax to the power of n plus b, where a and b are non-zero constants and n is a positive integer. As the input values of p increase without bound, the output values of p decrease without bound. So which of the following must be true? All right, so we're given a function. Okay, cool. We are given that a and b are non-zero constants. Okay, cool. And n is a positive integer. Okay. And as the input values of p increase without bound, the output values of p decrease without bound. So which of the following must be true? Here in this question, we're really just looking for the limits. So we know that the input values, so our x's, of p increase without bound. All right. So here we're looking at x as it approaches positive infinity because it is increasing. So it is going to the right, like a book. So limit p of x is equal to, and this is what we're trying to find. It's asking the y values of p decrease without bound. Oh, it's not asking, it's saying that the output values, which are y, are decreasing without bound. So in this case, that means that if we're looking at an actual graph and we're looking at this section, we're going down because our y is decreasing. So we're looking at the bottom half as it's going to the right. So what does that look like? Does that look like positive infinity or negative infinity? In this case, it is negative infinity. So right away, we can cross out C and D. Now we need to find out if A is negative or if A is positive. Well, you have to think about it in a way where it's like, okay, A can't be a non-zero, like, constant. So let's say A is 1. Okay? So now we basically just have x to the power of n. And it has to be a positive integer. So it can be either 2 or 3. All right? So we know if it's x to the power of 2, the graph would look either something like this, going all the way up, or something like this, going all the way down. Right? And then it crosses somewhere here. Okay, anyways. And then if it was odd, it would be something like this. If it were positive, so this would be a positive odd graph. And this would be a negative odd graph. So if this is a positive and this is a negative, and we're looking for as x approaches positive infinity, or as x increases without bound, we're looking at our right sides of our graphs. If we want our y's to decrease without bound, we have to look at our negative graphs. I'm sorry if it's really messy, but this is like the best way I can explain it. So in that case, that means our A has to be negative. So our answer is A. It is negative. A is negative because as x increases without bound, the limit p of x is negative infinity. All right? And that's the answer for that one. And then moving on to our last question. Okay. This question is saying the traffic flow at a particular intersection is modeled by the function f defined by f of t equals 92 plus 5 sine t over times t over 2 for 0 to 30 minutes. What is the average rate of change of the traffic flow over the time interval from 10 to 15 minutes? What does this rate tell you about the flow of traffic during this time? Make sure your calculator is in radian mode. So based off the whole question, we know we can use our calculator, and we're trying to find what the rate tells us about the flow of traffic during the time intervals given. So we know the car is moving from 0 to 30, but that's not what we're really looking for. What we're really trying to highlight here is 0 to 10, 15 minutes. Because it's asking what is the average rate of change of the traffic flow over the time interval from 10 to 15 minutes. So we can use t equals 10 and t equals 15. And we know we can use those because our signs are less than or equal to. If they weren't, we'd have to choose a number greater than 10 and a number less than 15. And obviously they can't be the same number. All right, so now what we have to do is plug in our numbers. So we have f of t which would be 10 is equal to 92 plus 5 sine t over 2. And F15 equals 92 plus 5 sine t over 2. Alright, and with our calculators, we can find out the answers are 96.690 and 87.205. Right, so this is our y1, this is our x1, this is our x2, this is our y2. Okay, so now we need to find the average rate of change. So we have to do 96.690 minus 87.205 over 15 minus 10, which is equal to 1.897. And this is telling us that the average rate of change is almost 2, but we're not asked to round. But basically the average rate of change is telling us that as the traffic flow continues, it is increasing. So it's moving up from the time intervals t equals 10 to t equals 15, right? So as the flow, I meant to say the flow of traffic, my bad. As the flow of traffic continues, it is increasing from t equals 10 to t equals 15, which is just from 10 to 15 minutes. And that is your answer. All right, thank you guys. I hope you guys have a good day, and this was a good review. Let me know in the comments how I did. Thank you.